Thank you very much. So one of the, for those who don't know me so well, I'm working on Plasma Mobile hello. Okay. I mean just. Hello. Okay, so I work on Plasma Mobile project and KD and so KD community started working on Plasma Mobile project in 2015. It was introduced as a community project in 2015 Academy. The goal was the project is to full control over information of the mobile devices and communication, and it should be inclusive to third-party software and not like some closed-down systems like iOS, and also seamless cross-device experience or convergence as you call it. And also we wanted to use the open standards which so today's my talk is about Plasma Mobile on the open devices. It doesn't actually focus much on the software side, but actually more on the hardware, and basically it doesn't even actually focus on the Plasma Mobile itself, but the layers below the Plasma Mobile. And so as a background, I took liberty of copying 2 slides from my last year's presentation. So last year's presentation, I basically provided updates about my work done in 1 year, and at that time I listed out some external factors that affect the Plasma Mobile project and some of the challenges we were facing at that point. So the external factors listed were basically the devices which are currently in the market have a really old kernel version. It's not reasonable to support them. For example, lots of people here will have a Nexus 5 which supports a 3.4 kernel. So yeah, that's a ancient kernel. And we also have a lack of open devices. The devices where we don't have some kind of device schematics and where you don't really know what's happening behind the scenes. So that makes it really hard to put something totally different than what manufacturer wanted to put on that device. And also like those devices requires a closed source binary blobs and PSPs to function. And so these were the external factors. And also I listed out some of the open devices or the programs which were known at that point. The one is Open Devices program by Sony, where they are basically trying to open source as much as they can. Other program is it's a community effort to support as much as devices we can support in the mainline Linux kernel. And there is also Fairphone, which provides open device schematics, and basically you can replace the parts of it yourself. And also, of course, it was a question mark at that point because it was merely a rumor that Purism will be building a Linux phone, but of course it's no longer a question mark, so that question mark should not be there. So back to present. So back to in this 1 year, we had worked with several projects and several community members and several corporations as well to make it easier for open software to be present on the mobile devices. It's entirely basically not structured effort, like it's basically different contributors working on totally different issues and trying to solve it. So when it comes to the off-the-shelf devices which are currently in the market, those comes with the old kernel version. But the Linux kernel have but in theory it can be supported by the current mainline kernel version. Just you need to do some work to add the SoC system support in the, for example, kernel. If it's there, you need to add hardware supports. And so basically some of the factors are DRM and GPU drivers. For example, there is a free Reno project which is a reverse engineered driver for the Adreno Qualcomm devices. There are Wi-Fi and Bluetooth drivers which needs to be open sourced into mainline kernel. And of course there is the phone part, which is the modem and telephony. So for that there is a project called Ophono which we use in Plasma Mobile. So more and more drivers should be added into Ophono. And also there is every hardware in the mobile, for example, camera, sensors, and everything. At that point, it was the next. In the past year, we had supported many Qualcomm devices with the mainline kernel. You might have read my blog post in planet.kd.org. So the Qualcomm devices, basically, the idea came to my mind when, basically I was starting to work on Plasma Mobile. There was a blog post by John, which showed that Nexus 7 2013 model was running. 2013 model was running a mainline kernel and the Android. So I thought, like, if it's a mainline kernel, we will have open drivers, and in theory, Plasma Mobile could work on it. And of course, I had no access to Nexus 7 2013 model, or that it was not easily available in market anyway. But I had a Nexus 5 device, which was a reference device for Plasma Mobile at one point. And so I got excited about this and started reading up on various things. And so I learned that Nexus 5 have a MSM 8974 board, and it was already supported to some level into mainline kernel. So I started by how can I add support for Nexus 5 into mainline kernel. Of course, that was a bigger technical challenge than that was a really bigger technical challenge than, it was a bigger bite than I could chew. I added some support. Well, some support is basically you get a kernel log over the headphone jack and you can press the volume buttons, but that's of course not usable for Plasma Mobile. Due to lack of time and lack of proper knowledge, I basically solved that project. But in past year, one of the other community members managed to actually extend the work I have done, and they actually managed to run a fully mainline kernel, and with the graphics and Wi-Fi, wireless, and those support on the Plasma Mobile. And then with the help of the community members, we started building a Debian-based system which can run along with this mainline kernel work done by the community members. So it was essentially thanks to people who were working on it, and the communities like Post-Market OS and Debian community, which was possible thanks to them. And those developers have now managed to port more and more devices, which is Sony Xperia Z2. And there is also Sirius, for which I am not exactly sure of the model number. And so basically now we have an experimental root file system which can be done on such devices which are already mainline. It uses fully open source Mesa stack instead of the hacked up libhybris and libhybris. So it's a great to have such open devices in the market. And also, like you might know this already. So KDE community is partnered with the Purism to build a Librem 5 and agreed upon to. And the Purism computers ran a campaign which was successful, and KDE community agreed to support Plasma Mobile on Librem 5. So it's expected to ship in January 2019, and it also uses a fully mainline kernel and fully open source drivers. And in addition to that, it also supports a kill switches concept, which is essential to privacy and security goal we as a KDE community have set up. So I talked about those devices, and here are some of the pictures. So it's a Sony Xperia's head device I talked about. It's running a mainline kernel version and Plasma Mobile on it. Then there is another Sony device running a post-market OS and Plasma Mobile. And here is another device running Plasma Mobile and Nexus 5. Sorry, not Nexus 5. So, and of course there is a Purism's development board which is also running a Plasma Mobile. So when we started Plasma Mobile project, essentially we were using libhybris, and we didn't actually explore the opportunities to. At that point, we didn't actually explore the possibilities to have open devices. But now we are now, due to community members and the corporations, we are actually in the position to build upon the open devices and have a Plasma Mobile running on the such devices. One of the interesting fact about the such devices is it makes development so much easier, because whole stack is familiar. You have a same Mesa stacks, you have a same drivers, you have a same wireless drivers, and you don't have to deal with the system which basically where you run where you run minimal Android inside the container and talk to it through various IPC, and you try to convert glibc based syscalls to the Android Bionic based system. And this will also make it so much easier to have multiple distributions to support mobile devices. Currently we just have, for example, KDE Neon based root file system on the Plasma Mobile, but if we are going to follow such open standards which are already getting used on desktop devices, it will make it very easier for other distributions like Debian or Arch Linux or OpenSUSE to build upon. And of course we need help. So you can talk to us in metrics channel, Plasma Mobile metrics.org, and mailing list is a plasmamobile@kde.org. We need help on various topics, for example, mainlining such a new devices, and we also need so far we have success in running mainline kernel on the only Qualcomm devices, but there is effort to have a Mali based reverse engineered graphics driver Lima. So we need help with such devices as well. There is also a community which can help you get started on mainlining your devices. And also we have a post-market OS project who have a very good guide on how to mainline your device. And yes, before I go to the questions, this is one of the very small thing. So this is the great. Basically, we were talking about vendor locking in my secret privacy talk. So this is actually one of the prerequisites. We want to see a file code which contains. So basically, this is the code. Well, this is the commit which says send the storage element settings. Hardcode the storage element to the Google using analyst Google. Provided if only one, otherwise Google search. And otherwise so this is the vendor lock-ins at its best. You are just forced to use the system which were developed by the vendor, and you cannot replace it with them. You cannot replace it with your own search engine. In the name of the features, like you are getting more features, they are basically trying to restrict your freedom. And I think as the career community, we are committed to not do such vendor locking. Like if you don't like the search mechanism used by Mobile, you can as well replace it with your own, or you can as well replace it with a third party. Yeah, so do you have any questions? Yeah, Bhushan, right.
If I recall correctly, logging which Google does actually is based on contracts, not on code. There are versions of Android which don't have the login, which don't force you to use Google search and so on.
Yes, and but still, basically this is the EOS which is coming directly from the Google itself. And then there are forks and forks. So forks may revert this. So, but still, Google actually enforces this. But the vendors may actually revert this thing if they want. So,
Hi, thank you for the good introduction. I'm a little bit confused about the main Plasma mobile. Many of the I've seen today is a very low level Linux stuff. Not much about actual Plasma. What do you focus on? Is this also working on Plasma? Because I was kind of hoping to see, how does Plasma work on mobile devices currently?
so for the Plasma mobile, it's basically the Linux system and set of various middleware, which basically allows us to do basically the firmware, for example, the firmware. And then there is the shell and user interface side, which shares most of the 90% of code with basically Plasma. That is a shell plugin. And we also have a kernel, which is the toolkit or framework to build your applications, which can be used even on the Android or iOS, or even on the desktop. So for Plasma Mobile, essentially is basically the Plasma Mobile is similar to how you use your own laptop. It doesn't actually change very much. It's just a custom user interface and various design guidelines, and yeah. Yeah, right.
All right. Do we have any more questions?
I'm wondering two things actually. Maybe you meant the Sony Xperia X device, which with the unknown set, because for that one the hardware is pretty open. Sony documented a lot of stuff, and I'm also wondering, do you think about joining efforts with the Sailfish people?
About joining efforts with the Shellfish people, I think in the past, it's a thing of past year, we started a collaborative effort with Selfish OS and Nemo Mobile and Ubuntu Touch people. which is called Halium. It's a separate to Plasma Mobile. So it works on a solution to use. It works on a solution to use Plasma Mobile on basically those old hardware where the only Android can be used. So yes, we are basically collaborating with the selfish ways, but as far as I am aware, they are not putting any effort in the mainlining devices basically. So my current presentation was about mainlining device. So basically you get to use very recent kernel like 4.18 or 4.19 and not the vendor provided 4.4 or 4.9. Yeah. Are we on time or?
So there's a reason why he talks a lot about Linux low-level stuff and why he's in charge of that and why there's this sort of weird separation of where does the Plasma stop and where does the mobile end, right? So I hack on Plasma. The way Plasma is architected is that we have a single executable called Plasma Shell, which loads the rest of the UI from a package, which means if you have a system that has Plasma Shell installed on it, in theory, as a third party, you can install an entire different UI into that system, right? So this is then why we call Plasma Desktop and Plasma Mobile, not because we like lots of keystrokes, but because in our minds those are kind of separate. Plasma is the runtime that enables you to write UI targeting a specific form factor, and Desktop, for example, is a project that implements a desktop UI for that. And Plasma Mobile is two things. It's also a project to implement a device-specific user interface, but it's also our effort to bring the Plasma runtime to mobile devices and all of the steps that go into that, like device image creation and so on, which he is the expert for, which is kind of why he focuses on that. Now, on the UI side of things, with some of the things we've done in the last year, we had an optimization sprint where we worked very hard on making this runtime more performant on low-powered ARM hardware. For example, the target device that we started with at the start of that sprint, which was a full week, from pressing the power button to getting to the UI, at the time we took 34 seconds. At the end of the sprint, it was down to 12 or something like that. And we cut memory usage by, I think, 150 megabytes and stuff like that. So on the runtime side of things, we've worked very hard to target a lower power envelope. Then a lot of the work that we're doing right now are in Kirigami. Kirigami is a KDE framework. It's a user interface toolkit that extends Qt and Qt Quick. What Kirigami provides is stuff to make your applications convergent, which means that with one code base you can target both a desktop and a mobile form factor. And we've been working, for example, on porting KDE's system settings application to Kirigami and all the modules in there to make them available on Plasma Mobile. We also see more and more of our KDE applications port to Kirigami or add Kirigami-based interfaces. So as time goes on, more and more applications pop up on the Plasma Mobile device image and become more usable on the mobile form factor. As for the shell specifically, there has been some polish. It needs much more work, for sure. So the way it works is that Plasma is very, very plugin oriented. Everything that you see on screen is in fact a plugin. Even the notion that you have a desktop, for example, on the desktop, or that you have a panel is provided by a plugin. The plugins are made aware of their constraints and they can adapt to them. This gives you the ability to do something like use one code base to provide desktop icons, but also have a file pop up on your panel, right? So what we do is we reuse some of the existing UI bits we have on the desktop in the mobile shell, like for example the network manager UI to pick your Wi-Fi or pick your connection is reused in the mobile shell, but adapts to the form factor a bit. What this has given us is a usable basic system that shares a lot of code. It needs a lot more work to be polished specific to that form factor, which the framework allows for. You can, on a file basis and on a sort of per UI screen basis, you can swap in form factor specific UML files, and that's work that is ongoing as well. So that's like a short overview of what's going on the UI side. And I think we're very excited to see more and more apps work on the mobile form factor. And as they pick up Kirigami to do that, Kirigami also gets better, which then creates this fortuitous cycle where it becomes more and more appealing to port your application to Kirigami.
Okay, thank you very much. It was very interesting in my mind.
We have a Plasma Mobile BOF on the Monday, so if you want, you can stop by. It's at room 122 and at 10:30.